Good morning, dear students. Today we will cover the last topic of the chapter S block elements, and this topic is chemical properties or chemical reactions of alkaline earth metals. That is group 2 or second A. We have talked about the general physical properties of group second A or group 2, that is alkaline earth metals. And there I have told you that they have large size. Though their size is smaller than alkali metals, but as they are the second element in any period, so their atomic size is large. Due to large atomic size, they have low value for ionization potential. Means for the removal of electron, energy required will be less. So we can say that removal of electron is easy. And if removal of electron is easy, then they will show metallic character, or they will be treated as electropositive elements. They have electropositive character less than alkali metals because their size is small, but they are classified as highly electropositive elements. As they are highly electropositive elements, so they are highly reactive in nature, as alkali metals are. So what types of reactions they are giving? Let us see. Number first is reaction with hydrogen. Alkaline earth metals react directly with hydrogen and forms hydrides with general molecular formula MH2. Calcium will form CaH2, magnesium will form MgH2 and so on. But remember, beryllium does not show this reaction, as beryllium is the first member of this group. The IV value for beryllium is more. So beryllium does not show this reaction, or beryllium will not directly combine with hydrogen to form MH2 type of hydrides. Formation of BeH2 is never direct. It can be indirect. We cannot use beryllium with hydrogen to form BeH2. Rest all other metals will form hydrides with the molecular formula MH2. CH2, that is calcium hydride, is also called hydrolith. Calcium hydride is also called hydrolith. These hydrides acts as strong reducing agents. And if we talk about their reducing character, if we compare their reducing character with the hydrides of the alkali metal from the same period, then their reducing character will be less. And as we move down in a group, the reducing character of hydride increases. Next one is your reaction with oxygen. These metals burn in presence of oxygen, as they are highly reactive in nature. On reaction with oxygen, they forms oxide with general molecular formula MO, where M is M plus 2 ion and O is O minus 2 ion. So this is the formula for normal oxide of alkaline earth metals. Next one, here BeO is amphoteric in nature, means beryllium oxide exhibit acidic as well as basic property. In presence of strong acid, BeO will start behaving as a base. In presence of a strong base, BeO will start behaving as an acid. That's why it is amphoteric in nature. Ampho means dual, teric means nature. It is having dual nature. It can act as acid, it can act as a base. But at a time, it will act as an acid or it will act as a base. At the same time, it cannot act as a base and an acid. We know it very well that metals form basic oxide. Most of the metals form basic oxide, but there are few oxides which are amphoteric in nature. BeO is one of them, while rest other oxides, calcium oxide, magnesium oxide, strontium oxide, beryllium oxide, will be basic in nature. These oxides react with water and produces hydroxides. Hydroxides are the basic compounds. If we compare the basic character of these hydroxides, then as we move down in a group, the tendency to give hydroxide ion increases, or we can say basic character increases. Reason is simple, as we are moving down, the ionic radii of alkaline earth metal increases, due to which force of attraction between the cation and an ion, that is hydroxide ion, decreases, so hydroxide ion can be released easily. So here is your increasing character for basic character. BeOH whole twice is less basic than MgOH whole twice, is less basic than CaOH whole twice, is less basic than SrOH whole twice, is less basic than BaOH whole twice. It is amphoteric, while the last one is the most basic. Barium hydroxide act as a strong base. Its basic character is comparable to sodium hydroxide and potassium hydroxide. Then we have next one, reaction with halogens. They react directly with halogens, and on reaction they forms MH2 type halides like BeCl2, CaCl2, MgCl2, etc. So it is about reaction with halogens. Then we have next one, reaction with nitrogen. It is one of the important property exhibited by alkaline earth metals. Nitrogen gas is highly inert in nature. Very few metals react with nitrogen directly. So when this alkaline earth metal are made to react with nitrogen, then they will form nitrides with molecular formula M3N2. And these nitrides are in the form of solid, better to call them crystalline solids. They have a definite geometry. They have a definite shape. That's why these are called crystalline solids. Nitrite is N-3 ion. Example of nitrite, Ca3N2, Mg3N2, that is calcium nitride, magnesium nitride, etc. One of the important property of this nitride is that they react directly with water and produces hydroxides with the release of ammonia. Two basic compounds are produced at the same time. There is no other reaction where two basic compounds are produced at the same time. Or we can say there is a few reactions where two basic compounds are produced at the same time. It is one of them. So Ca3N2 is formed when calcium is made to react with N2. Calcium nitride. Now calcium nitride when made to react with water, it produces calcium hydroxide and ammonia. Two basic compounds at the same time. Calcium hydroxide is a basic compound. Ammonia is also a basic compound. That we will come to know in chapter chemical equilibrium. Why ammonia is basic in nature. Then the last one, solubility in liquid ammonia. What happens when alkali metals are added to ammonia? Alkali metal get dissolved in ammonia. What happens when sugar is added to water? Sugar gets dissolved in water. We get sugar solution. So when alkali metals or alkaline earth metals are added to ammonia, then they get dissolved in ammonia and we get solution of alkaline earth metals in liquid ammonia. This solution is having deep blue color due to presence of ammoniated cation. This metal will react with X plus Y molecules of ammonia. This metal will lose 2 electrons and form M plus 2 ion. This M plus 2 ion will get surrounded by X molecules of ammonia and it is written as M plus 2 NH3X, which is called ammoniated cation. 2 electrons which are released also get surrounded by ammonia and it is written as 2 NH3Y minus charge because over electron we are having minus charge. This is called ammoniated electron. So due to presence of ammoniated electron, it is having deep blue-black solution. The color is deep blue-black. And the solutions are highly conducting in nature. The cations and anions present are responsible for electrical conductivity. We need ions, positive and negative ions in solution. If ions are there, then electrical conductivity will be exhibited. So that's all in chemical reactions of alkaline earth metals, and it's all over in chapter S block elements. Thank you and have a good day.